Hi, and welcome to another lesson. Did you ever wonder why your teacher makes you balance chemical equations? Well, it's all about this wonderful thing called conservation of mass, more specifically, the law of conservation of mass. Whenever we have matter, one of the biggest premises that goes with chemistry is that matter cannot be destroyed or created. So whenever we do things, it's not like we can magically do a Harry Potter and go abracadabra and something will appear. No, that doesn't work. So what they actually said was that what we start off with and what we finish with should be the same number of atoms. Now, as I've said here, this whole process is a law, and a law means always true. So no matter what you do in science, it is always true that the mass of your reactants, the total mass, in other words, if I add up all the atoms in my reactants and all the atoms in my products, it will be equal. So this is a very, very important premise, and this is why we're doing this video. So let's look at what we had to start off with. You should have recalled, and you would have seen lots of equations, and we normally have a simple meaning to it. If we do and look at what's going on, we simply say reactants are what we start with. This is what we end up with or finish with. And the arrow, I like to think, means changes into. So what we start with changes into what we end up with. And that's simply put. Now keep in mind that everything we start off with is called reactants. Everything we finish up with are called products. So let's look at an example. If we get some magnesium and burn it in air, and as I've said here, it's really burning it in oxygen. It would get so confusing if we had to include all the gases in air into what's going on. So what we think is happening is the magnesium combines with the oxygen to make a compound called magnesium oxide. That's our word equation. We've got no idea how many of each atoms are there, so that's why we go to symbols. So what we do is, in a symbolic equation, we put in what we know. Now we know that Mg is magnesium. It's straight from the periodic table. We know that oxygen gas in the air is O2. It's not O, it's O2. And we also know that magnesium oxide is MgO. So what we have to do now is simply count, and we count up the numbers of atoms in each one of these. So look here at the moment, we've got one of those, two of those, one Mg, one O. So that's not quite good enough yet, is it? So I'm going to use the O2 here. I'm going to use this to help me out over here. If I want to show two O's, there is only one way I can do it, and that is to show it as this way, right? By putting a 2 here. And that means now I've got 2 Mg and 2 O, like a math thing. Whenever you put 2 in front, you have 2 of everything that follows. So now that's not right. Now I've got 2 of those. So far I've got 2 magnesiums and 2 oxygens on my products, and I've got 2 oxygens here. So the only way I can fix it up is to put a 2 there. And now I have 2 Mgs and 2 Os here. In other words, my mass is the same as my mass here, because I've got 2 Mgs, 2 Mgs, 2 Os, 2 Os, balanced. That's what we mean by balancing equations. Now let's look at a slightly harder version. One of the big equations you are doing at the moment is photosynthesis. And our word equation follows the same idea. We've got carbon dioxide plus water changes into a simple sugar, now we normally give the formula as glucose, and oxygen gas. Alright, so let's work through and see if we can balance this one. So the symbolic equation, I'll put it in here. The formula for carbon dioxide is CO2, we should know that. The formula of water, I'm very surprised we don't know, is H2O. Sugar though is much more complex, C6H12O6, and oxygen gas is of course O2. So we're going to look at this and we're going to try to balance it out here at the moment. So I'm going to start by simply writing down the number of each atom we have. Now keep in mind we're trying to make sure that at the end all the numbers are the same. So I've got 1 carbon and 2 oxygens. I've got 2 hydrogens and 1 oxygen. Over here I've got 6 carbons, 12 hydrogens and 6 oxygens, and I've got another 2 oxygens here. Now by any stretch of the imagination that is nowhere near balanced. So what I'm going to do is look at over here, and I'm going to use this information to see what's going on, see what's happening. Right, here I've got 6 carbons, here I've got 1. So I can make that into 6 by simply doing this. Putting a 6 there. Now I've got 6 carbons and I've got 6 times 2 or 12 O's. I've still got 2 hydrogens, still got 1 oxygen, and I've got that. But now I've got the number of carbons equal. So how about I try doing the same thing with the number of hydrogens? I've got 12 as my product, I've got 2 here. So if I times that by 6, now I've got 12 hydrogens and 6 oxygens. Now at the moment I've got 6C, 12H, and 12 plus 6, 18O over here. Right, all I've done is I've brought them together and added them all up. Over here I've got 6 carbons, I've got 12 hydrogens, and I've got 6 oxygens. So that means I have to find 18 minus 6 or 12 oxygens. I've got to have 12 oxygens there somewhere. Now that means I can do this. And if I do that, it means I've got 6 O2s, and 6 times 2 is 12. And that means now I've got 12 oxygens here. So now I've got 6 carbons, 12 hydrogens, and 18O here. So that means I have got that and that are equal. That is how you balance an equation. And I hope that's clear, but let's see if you can do a couple later. I'll work out a couple for you to do as well. All right, that's all for now.